Yes. Hi folks, guys. Let me tell you one thing that this 14th question is now finished. And okay, so it was the ending of this question 14 you were doing. Okay, now the final answer is this one. So this is twice b minus a. The solution we have just I have rubbed the rest one. I mean whatever I reached up to this that I rubbed. Now the question is this. We consider x equal to, we substitute x equal to a cos square theta plus b sin square theta. Then we found out dx equal to this. We change the limits from a to b to 0 to pi by 2. This was 0 to pi by 2. Okay, after that. Okay, then finally this is the answer. This answer I am writing here because the whole process I have already discussed. Okay, so just see. Okay, the previous this lecture. I mean, just a series of this lecture of this. That is going to be discussed about. Now in this case answer is same. This is b minus a whole power n plus 1 twice into, sorry, this was coming and this was gamma n plus 1 divided by twice gamma, it was twice n plus 4 divided by 2, dividing by 2, twice m is n, twice n is n, after bringing it to this 4 is 2, m plus 2. This is the gamma of this value. Okay, after dividing by 2. Now this is twice of 2 to cancel out this 2 and this 2. Finally we have obtained b minus a, let me write here. And this is what? We know that gamma m plus 1 is 1 lesser than this factorial. This is factorial n, factorial n, factorial n, factorial n into b minus a whole power n plus 1 divided by, this is 1 lesser than this factorial n plus 1 factorial. Okay, so this is the right hand side. This one which we have obtained here, hence proved. Okay, this we have discussed about. I have already discussed about this whole what is x minus a, what is b minus a, that we just calculated, and this dx we substituted. After this whole the process is now ends after this one. Okay, so this is question number 14th. Now let me take question number 15th. What is question number 15th say? Okay, let me take question number 15th now. Question number 15th is what kind? Let me check. Okay, so question number 15th is, it says that if, what does it say? If fmn, okay, fmn equal to, fmn equal to 0 to pi by 2, 0 to pi by 2, here cos m, this cos mx sin, sorry, cos nx, it is cos nx, it is cos nx into dx. Then prove that, then prove what we have to prove here. Prove here that fmn is equal to n upon m minus n f m minus 1 comma n minus 1, okay, sorry, n plus 1, this is first is n plus 1, okay, or is equal to m upon m plus n, okay, f, this is fmn, m minus 1, then n minus 1, okay. These are the two similar type of question, but we have to prove here the reduced formula is f m minus 1 n plus 1. This is increased value of cos nx is cos m plus 1x. That this is our okay. Now in this case this is m minus 1 sorry, and n minus 1. These two we have to reach out. Okay, so fmn the same value. fmn is equal to, okay, so fmn is equal to this way. Let me discuss about this. Okay, fmn is equal to this. We have here the two proofs which we have to do. Now, let me discuss about question. Therefore, here Fmn equal to 0 to pi by 2, 0 to pi by 2, okay, is cos nx dx. Okay, so this is equation number 1 that we take. Now let us integrate it by parts. Integrating it by parts. Integrating it by parts. Considering cos nx as the first function and cos nx as the second. Considering that we take cos nx as the second function. Cos nx for integration and cos mx for differentiation and cos mx as the first one. Okay, so differentiating it with respect to integrating it by parts, we get, what do we get here? For first, let me take sign of integration. This is cos mx. I am not writing the limits. Still, I am not writing, or at the moment I am not writing limits. After finally, when we have reached the result, then I will apply the limits. Okay. This is cos mx into cos nx. Now this integration will be cos mx, first function as it is. Integration of second is cos nx, that means sin nx upon n, positive value for integration of cos nx is positive, sin nx upon n minus sin. Now differentiation of cos mx, that will be n into cos raised power n minus 1 x. Now cos x is again differentiated into minus sin x. Okay, into integration of cos nx, which is minus sin nx upon n dx. Okay, now let me take for the first let me write it here. This is cos raised power mx sin nx upon n whole upon n minus sin, this is m upon n here. This is plus sign, minus plus sign. This is cos raised power n minus 1 x sin nx dx. Okay, if I write in case of sin x sin nx something, if I replace this, and then finally we get this answer. Let me first write what is, we know that what is cos n plus 1 x. We know that, let me write here, we know that cos n plus 1 x equal to, what is this? This is cos a plus b. It will be cos nx into cos x minus sin nx into sin x. This sin nx, this value, we want this taken to this side. This implies that sin nx equal to cos nx into cos x minus sin. This is cos n plus 1x. This one taken to that side. Now, if I substitute these two values in place of this here in the first equation, and this is the second equation, this is the third one. This we are taking. So substituting this value, substituting this value in second we get, what do we get here? Now if I write here the limit 0 to pi by 2, at pi by 2 cos pi by 2 is 0, so at 0 it is and 0. Let me apply the limits now. Therefore let me write here 0 to pi by 2 cos mx cos nx dx is equal to limit 0 to pi by 2 here. Okay, here 0 to pi by 2. This is 0. Before that, let me I'll substitute these values cos nx cos x minus cos n plus 1x. This I will substitute here, but before that this is 0. This in both the cases when pi by 2 limits is applied. Okay, sin n pi by 2 is okay 1, but cos pi by 2 0. At 0 lower limit, sin 0 is 0. So cos 0 is 1, okay, but in both the cases this value is 0. 0. Plus this is m upon n. Let me write 0 to pi by 2 cos raised power m minus 1 x into place of sin x or sin nx sin x is this value. This is cos nx into cos x. Okay, minus sin, this is cos n plus 1 into x into dx. Now let me multiply this and separate this value. It will be equal to, let me write here, m upon n sin substitution 0 pi by 2 cos. Now if I multiply this to this first term, cos 1 power and this m minus 1 power, it will be nothing but cos nx into cos nx into dx. This is the same value imn which we started with, cos mx cos nx, same value. Okay, so this is with plus sign here, plus sign here. This will be minus sign second one, this one will minus sign here, and we come in sin of substitution 0 pi by 2. Okay, this is cos m minus 1 x into cos n plus 1 x. Now this is minus m. Now let's write here. This is m upon n I mn. This is I mn. Same formula. This is minus m upon n. This is I n minus 1 for fm. That is given as fm. Okay, let's write it as fm. I'm sorry. It's not in but fm. Fm given to us. Let me write here fm. Mn m minus 1 and n plus 1. Okay, so this is this value, but let me still solve it. If I take this fmn, this side, this is fmn. Okay, so taking this this side. Now this I want to keep. Okay, so instead of this value, let me write here. What do we get here? 0 to pi by 2. From this value, this second one, if I take this transpose fmn m by n fmn to left hand side, 1 minus m upon n fmn is equal to this value, which is minus m upon n. This is f n minus 1, sorry, n plus 1. Okay, this is m minus 1 and n plus 1. Okay, so if both I can write this 0 to infinity cos m minus 1 into cos n plus 1x. That's the thing. Now let me right here this one. This we are doing. So this is n minus m. So therefore fmn is equal to that here. Therefore fmn is equal to fmn is equal to this n minus m upon n, and n cancel out. It is minus m upon n minus n x n minus 1 n plus 1. This like this. Okay. Now in this case, if I take minus and common, it will be n positive upon n minus n. F n minus 1 and n plus 1. Okay, this is proved. Fmn. Therefore, Fmn is equal to m upon n minus n fm minus 1 n plus 1. This is the first rule, and it's proved. The first one is proved, and it's proved here. Okay, this is the first proof. This one is proved. Now for second, if I substitute sin nx sin x in terms of cos n minus 1, let me write that. Okay, so let me write this here. Now in this second equation, this one, if we substitute, we know that cos n minus 1 into x is equal to cos nx minus x. This is equal to cos nx plus sin nx sin x. Therefore, value of sin nx sin x is implied sin nx sin x equal to cos n minus 1 x minus these two values, cos nx into cos x. Substituting this value of sin nx sin x equal to cos n minus 1 x into minus cos nx cos x in this case. Substituting this value in equation second. Substituting this value in second, we get, now we have applied this 0 here. So I just proved that if I apply pi by 2 and 0, both the limits upper limits of 0, this only will be left. So what is that? Let me write it here. Okay, so this is, let me write here. What do we get? Therefore fmn, this is fmn. Fmn is equal to 0 plus m upon n sin of integration 0 to pi by 2. This is cos raised power m minus 1 x within bracket these two values. What are those two values? Let me write here. This is cos n minus 1 x minus sin cos nx into cos x. This value I have substituted from that solution, you know this, into dx. If I multiply and separate each term of this, you will get n upon n sin of integration 0 to pi by 2. This is cos raised power m minus 1 x into cos n minus 1 s ds. This is minus sin m upon n value into sin of integration 0 to pi by 2. Now if I multiply cos m minus 1 x into cos x, to cos nx, cos x into cos m minus 1 x will be cos mx right constant and cos nx as it into dx. So this is the same value and fmn. Okay, this is minus m upon n fmn, and this is f m minus 1 n minus 1, this value. Let me write it here. Let me write L. Where is it? Let me write it here. Finally, for the second part we are doing fmn. If I take this value, which is fmn, so let me write fmn is equal to, this value is m upon n f m minus 1, this one, comma n minus 1, this value. So this is forward cos power m minus 1, cos angle n minus 1 x, which is m minus 1 n minus 1, minus sin m upon n, this is fmn, only fmn m n, the same function as we started with. Taking this to left hand side to be 1 plus m upon n, the coefficient. Fmn is equal to m upon n is value f m minus 1 n minus 1. Okay, let me further solve it. So what do we get here? Here we get take it. What do we get here? Here it is m plus n divided by n Fmn is equal to m upon n f m minus 1 m minus 1. Okay, let me take. Now if I divide by m plus n upon n, and m will be cancelled out. Therefore Fmn is equal to m upon m plus n. This is m plus n. Okay, f n minus 1 comma n minus 1. And proof, this is the second part, m upon n plus n. Proof, second part is proved. Second part is proved or is obtained. We have obtained the second part here. This is the solution of these two parts we have solved. Okay, so finally, question number 15 is done. Let's talk about 16th question. What is question number 16 say? Let me check. Now question number 16 is of what kind? Let me check it. Now it says question number 16 is this. Find a reduction formula for IMN where IMN is equal to this value. Now here initially actually there was a misprint here. It was not sin Bx but it is sin Nx. Cos m power cos x whole power m into sin Nx not Bx because this mn, so angle will be n the of sin not B. Okay, so here we have IMN question number 16. Here IMN is equal to sin of integration 0 to pi by 2. Okay, this is cos raised power mx into sin nx into x. This is IMN. Okay. Then reduce that IMN is equal to this we have to reduce. Okay, let's check it. So here we are given this. Let me first find out what is IMN is equal to. The reduction formula of this. What is the reduction formula? Find a reduction formula for this. Okay, so find reduction formula of this. Find this is the objective here. What is that? Find a reduction formula. First is to find a reduction formula. Find a reduction formula. Okay, now let me solve it. Integrating it by parts. Integrating it by parts. Taking cos mx as first function and sin nx as second. Sin nx as second. We obtain or we get here. Okay, so this IMN is equal to 0 to pi by 2. We are solving here IMN is equal to 0 to pi by 2. This is cos mx sin nx dx is equal to. Now again I have to apply the limits later, but first let me find out what is this value. So it is sin of integration cos ms sin nx dx. So this is equal to, and we first solve this. We will get so cos mx as it is integration of sin nx is minus cos nx upon n. Okay, with minus sign, this is n sin of integration. Here is cos is power m minus 1x. Cos is differentiated is minus sin x. Cos differentiation is minus sin x. Okay. Then we have to find out this value. No problem. Let us solve it further. What do we get here? So this is F and N. Okay. 0 to pi by 2. Okay, no problem. Now let me talk about this. So this value will be, okay, cos n sorry, minus sin x into this value, which is minus sin, again minus sin, but minus cos nx upon n is dx. This is integration of second part. Differentiation of first part. On this, others are thinking that is minus or minus. There are any difference of this? No. Now this is cos n minus 1 x. Okay, and we are taking first. We are differentiating. Cos x is differentiated as minus sin x, and the sin nx is integrated as minus cos nx upon x. That is there. Let me first solve it further. This is minus cos nx into cos nx upon n minus sin is n upon n upon n upon n minus minus minus, three minus are there, minus minus minus, negative n cos raised power n minus 1 x, okay, into cos nx into sin x into dx. Now because we have to find out n minus 1, n minus 1, is it n minus 1? Yeah, reduction formula will be n minus 1, n minus 1 maybe, or n minus 2. Up to that we have to find out. What is that? Okay, now let me substitute the value of cos nx sin x. You know that we know that sin n minus 1 x equal to sin a minus b. This is, first it will be, we have sin a cos a minus cos a sin, is sin nx cos x minus sin. Because in case of sin is similar. If it is minus, then in between it will be minus. But in case of cos, if it is minus, then it is positive. If it is plus, it is negative. In case of cos, but in case of sin, it is similar sign here. It is cos nx into sin x. Now the value of this cos nx sin x we have to find out. Take this to the side. It will be cos nx sin x, which implies that equal to, this is sin nx cos x minus sin n minus 1 into x. Now let me substitute this value here in this equation. So let me take first equation. And this is the second one. In second, substituting this value in second, substituting this value in second, we get second equation. So here in the second equation, cos nx sin x, cos nx sin x is sin nx cos x minus sin n minus 1x. Let me substitute this value here. What do we get? Let me write here. Okay, now let me apply the limits also. Okay, so what will be there? So this will be, let me write it was 0 to pi by 2 cos nx sin nx dx equal to limit we have to apply here. What is the limit here? We write, or if I write limits here, okay, let me first write it. Mx into cos nx upon n, limits are 0 to pi by 2 minus m upon n 0 to pi by 2 cos n minus 1x. Base of cos nx sin nx, we have to substitute this value. This is sin nx into cos x minus sin, this is sin n minus 1x whole dx. Okay, this is the value which we have substituted of cos nx sin x. Okay, this is the value. For multiplying this, let me first apply the limit here. In case of pi by 2, cos pi by 2 0, this will also be equal to 0. at 0, what it will be? It will be minus minus plus. Cos 0 is 1, cos 0 1, it will be 1 upon n positive. Minus, this is n upon n. Okay, now let me solve these questions. This is 0 to pi by 2 cos. If I multiply this cos x into cos n minus 1x, with cos n x. Why? Because cos n minus 1x into cos x into sin n x. This is the same function which we started with. This is an IMN or FMN with IMN. Same function. This can be taken to the left hand side. First let me write the second function also. This is minus minus plus here. This is plus sign. This is m upon n. Sin of integration 0 pi by 2. This is cos n minus 1x sin n minus 1x dx. This is im minus 1 n minus 1. Okay, so what do we get here? We have obtained this as 1 upon n minus this is m upon n. Let me write here. This is I n n plus m upon n. It is I m minus 1 comma n minus 1. This is the formula here, and this is FMN or IMN on the left hand side. If I take this IMN on the left hand side, it will be added to this. Let me write it out. So the final value, what is that? Let me write it here. So we obtain this 1 plus m upon n into IMN or IMN equal to 1 upon n then minus, sorry, this is plus 1 plus m upon n. The second one will be left over here. This is I n minus 1 n minus 1. Okay, this value. What the formula from this is I and therefore will be equal to. Now if I solve it, this is m plus n upon n. N will be cancelled out. It will be 1 upon m plus n plus m upon n plus n. Why? Because m plus n upon n, we have to divide each term in the right hand side by